Okay, so that was a terrible place to end in part two. But what I was trying to say is taking your temperature every day and getting the same temperature every day, which could happen for months as long as you don't get sick, um, would be reliable, but there would be no validity to that when it came to testing your IQ. So it can be reliable without being valid. This part here is probably the most important thing that we will learn about the entire semester. In fact, the instructor that teaches the more advanced classes in research and also the statistics class said if there was one thing you were to learn this semester, it was to understand the difference between the independent variable and the dependent variable. And that sounds like it should be really easy, but sometimes it's very confusing. So we're going to do a tremendous amount of work on it this semester. A variable is, they're given special names that only apply to experimental investigations. One is called the dependent variable and the other is called the independent variable. So in an experiment, the researcher is looking for the possible effect on the dependent variable that might be caused by changing the independent variable. So the independent variable is whatever that variable is that the researcher manipulates or changes, and that variable is assumed to have a direct effect on the dependent variable. And the dependent variable is the variable the experimenter measures after making the change to the independent variable that we assume is going to affect that dependent variable. So let's look at some examples because that really doesn't say a whole lot there, does it? So you might change the type of information organized or random that's given to participants to see what effect this might have on the amount of information that's remembered. In that particular example, the type of information is the independent variable because it changes, and the amount of information that's remembered is the dependent variable because that's what it is that you're measuring. So dependent is what you're measuring. So suppose I want to measure the effects of alcohol on driving. I would have to try to ensure that there wasn't any extraneous variables that didn't affect the results, but we'll talk about those in a minute. If I want to measure the effects of alcohol on driving ability, what would be the independent variable? If you said alcohol, then you're right, because driving ability is what it is that we're measuring. So let's talk about some of these extraneous variables just really quickly that could happen in this example. So if you were having them drive a Ford Focus and you have some of your people in your group that have driven a Ford Focus or own a Ford Focus, then they might be able to drive better because they've drove that kind of car before, regardless of how much alcohol that they've consumed. Well, I guess there would probably be, anyway. Familiarity with the test. Some people may do better than others because they know what to expect in this driving test. How used to drinking they are. If I was the one that was being given the alcohol, I probably wouldn't be able to drive very well because I don't drink. So that would be, you know, a lot rougher on me than someone who drinks a 20-pack of beer a day. They would probably be able to drive much better than me. The other thing is who has a full stomach, who ate before they started drinking. We know that that affects the has some effect on how alcohol. Um, Boy, that's a lot of effects, but how alcohol affects people. So there's a lot of different things that could be taken in that are extraneous variables, and they're not controlled. So you have to be careful in your studies that they don't become confounding variables because they really can go on to affect the experiment. We're going to come back and